Hello, can you hear me? Can anyone tell if I'm audible?
Yes, madam, you are audible.
So, Ganeshan, you're saying something?
No, I am saying just you are audible, madam.
Okay, thank you. So, now it is time, but I think we'll at least wait maybe 5 minutes because this is first class. I want all students to come because otherwise we'll keep on getting interrupted. So, whoever has joined already, thank you. But let's wait some minutes for others also, okay? Okay, it's already been 5 minutes, but again, people are coming. So I'm sorry to keep you all waited, but again, since it's the first class, I wanted more people to have joined already. So let's okay wait 5 more minutes. After that, we'll start the class. Okay, thank you. I think now we can start our class. Uh, could any one of you please tell me if my screen is visible to you guys? Is my video, audio, and screen visible? Okay, thank you, Prasad. So, I'll show my slide now. Actually, I would appreciate if somebody unmutes themselves and answer, because now if I'll make this slide full screen, I won't be able to see your chats, I think. So if anybody wants to ask something in between, they should unmute themselves and ask and then mute themselves. Okay? Okay. Okay, so good afternoon, everyone. This is the uh, Experimental Physics 1 course, which is the course instructor is Professor Amal Kumar Das. And for this course, this is the first interaction session, and I am Mrinalini, the MRF Research Scholar from University of Hyderabad. For this course, I'll be taking this interactive session every Saturday from 3 to 5 p.m. In this interactive sessions, we'll be going through brief summary of what Professor Das had taught in the week, and then we'll be solving some problems that were not from this year but previous year assignment. So, as in this week's lecture, we saw the mainly the sir taught about basic tools and apparatus that we see in any lab, experimental lab. So he talked about nuts, bolts, screws, screwdrivers, meter scale, slide caliper, screw gauge. So we all have seen this is a screw or bolt, you can say. In this picture, this thing is called the nut, and these with this screw like thing is called bolt. So this together is called nut bolt. This is a screwdriver, we all know. This is a meter scale we use to measure length of any object. These are another set of devices. They are also used to measure dimension, but we'll see later in the lecture how they are different from a usual meter scale. So actually all these things I think you guys have already studied in your 12th, but again we'll be summarizing it, that's fine, and whatever we have doubt we'll discuss those things. So what whenever we carry out any measurement, be it length or anything, one thing we need to make sure is how correct that value is. Just give me a second. For example, say we measure distance from a place A to a place B, we can approximate and say that the distance between these two places is say 200 meter or 250 meter. So our approximation is okay, but say if we want to make road between these two places, then approximation will not work, right? In that case, we need to know in a way exact value, or approximation will not work, but we will need to find out more accurate value of distance between these two places. Similarly, uh, when we carry out any measurement, just a minute. Okay. Yeah, so whenever we carry out any measurement in our experimental lab, we want to know the measurement that we have done, how accurate that measurement is, and how precise those measurements are. And we'll see now what do we mean by accuracy and precision. So from this diagram can give us an analogy of what we mean by accuracy and precision. I'm sorry, this will keep on happening. Anyways, let's focus here. So this diagram here gives us analogy what we mean by precision and accuracy. So accuracy tells us that how close we are to the true value, in the sense like, see, if we imagine we are playing a game where we need to hit the center of this target using a toy gun, say, then think that these black dots are the you have made attempted many times to shoot the center of this target, and these are the places where your toy bullet landed. So we know the center of this, we know the center of, sorry, let me make it zoom, yeah. we know the center of this will be the exact place, but if our bullet has landed on these places, so we can say it's not accurate and it's not precise. What do we mean by precision is that how many times we are repeating this shooting the target, and we are how close we are, I mean how our values are similar in every repetition. Like here it's not accurate, of course, because it's far away from the center, we are not able to hit the center. In this case, we our ability is that much that we are do all our attempts were close, but it was far away from the place where we wanted it. So it's high precision, but accuracy is low. Whereas if we see this picture here, all these attempts are far away from each other, but they are very close to the center of the target. That means the precision is low, but the accuracy is high. If we see this one here, all the time we attempted to hit the center, they are all close to each other and they are all close to the center of the target. That means this resembles high accuracy and high precision. So in the similar way, when we carry out any measurement in our experiments, so there also we talk about accuracy and precision. And accuracy means how close the measured value that we have obtained, how close is that to the actual value. And precision means what is the resolution or limit the quantity is measured. We'll try to understand these two things again with an example. Say I have a, sorry, just a minute. Just sorry. Yeah, guys, I'll request all of you to join a little earlier so that next time it doesn't interrupt our classes. Sorry. Or maybe next time I think, or I should wait a little more for more people to join together. But anyway, we'll see how it has to be done. So, accuracy and precision. So, say I have a rod which is actually of say 3.678 centimeter length. From somehow I know that this is the length of this rod. Now, say I do two experiments. In first experiment, I am using an instrument which can measure 0.1 centimeter least count it has. So this is the minimum value it can go to. Using this instrument, if I am finding out the measured value, say 3.5 centimeter, whereas I am repeating the same experiment using another instrument whose least count is 0.01 centimeter. This is 0.01 centimeter, and using this I am finding out the measured value to be 3.38 centimeter. Now from this we can see that in the first experiment, so actual value is 3.678 centimeter. Using first instrument, I found out the value to be 3.5 centimeter, and using second instrument, I am finding the value to be 3.38 centimeter. Now we can clearly see that this first value is closer to the actual value rather than this second value. That means this first measured value is more accurate because it's closer to the actual value. But the second value, it's less accurate, but it's more. It's more precise because its least count is more, means it's going to higher resolution. So people who have joined late, actually we have already started the lecture. So if you have any doubt, you can unmute yourself and ask me in between, okay? Okay, so I hope this accuracy and precision example is clear to everyone. That again, I'll just summarize. 3.678 centimeter was the actual value of, suppose, this rod that I have. I measure its length using one instrument, which gives me the measured value to be 3.5 centimeter. I am using another instrument to measure the length of the same rod, but here the least count of this instrument is 0.01 centimeter, and when I measure, it gives me 3.38 centimeter. So I see that this first value is more accurate because it's closer to the actual value, that is 3.678, but the second value, which is less accurate but it's more precise value, because here least count is more, means it's giving me more decimal digits. Okay, so yeah, so we use various instruments for measuring the dimensions of any object. Now we'll talk about the instruments that were discussed in this week's lectures by the professor. So those are vernier calipers and screw gauge. First we'll see vernier calipers. Again, these things we have already, I think you guys have already done in your till class 12th, but again we'll just have a glance, and then later we'll discuss problems based on previous year assignments. So vernier caliper is used again. So okay, we can explain that in a meter scale. Sorry. Okay, I'm using this writing pad for the first time, so I'm little losing where to write. Sorry. Okay. So in a meter scale, we have say 1 centimeter has, this is not to be scaled, I'm just showing. 1 centimeter is divided into 10 divisions, right? Uh, yeah, it's, sorry. I mean, this 1 centimeter is divided into 10 divisions. But again, if I'm measuring using this, then the least I can go is 0.1 centimeter, right? 1 millimeter is the least count on any regular scale that we use. But if I want to, because now we have understood what we mean by accuracy and precision, then I'll start using these terms. So if I want to go and get some precise value of any say anything I have, and I want to measure precise value of its dimension, then using this usual 15 centimeter scale that we have in our classes, using that I can only obtain 0.1, 0.2, 0.3 centimeter. But uh, this is one, two, three. This is 2, this is 1. Imagine this is 1 centimeter, this is just for explaining. So if I'm measuring something and it is in between here, coming till here, say from 0, it's coming till here. So in that case, I can see it's more than 1.6, but it's less than 1.7. So approximately I can say that it's around 1.6. But if for some purpose I want to find out even more precise value of this sheet. Say it's a gold film, we know how precious gold is. So if we want to sell gold or buy gold, then we of course don't want approximately that unnecessary amount we are giving or taking. We want to pay for every particle of gold, right? In that case, we'll like to know exact size of that gold sheet if we are buying, say. So in that case, if I want to know what is the value, like what is the value I'm missing between 1.6 1.7, so we have different instruments to measure these kind of things. Like one is vernier caliper. Vernier caliper is an instrument which can help us in finding out even precise value of any length. So vernier caliper, uh, yeah. So vernier caliper looks like something like this, and now we, yeah. So So this is the diagram, sketch diagram of vernier caliper, where this is called the main scale, which is like our usual 15 centimeter scale. So the 0 to 1, between 0 to 1 there are 10 divisions, and this represents 1 centimeter. So till 8 we can see it's still there, but in this diagram only this much we have kept. So this 0 to 1, it's 1 centimeter and it has 10 divisions. That means this main scale, least count of this main scale is 1 millimeter. Whereas there is one more part attached to it, that is called vernier scale. In this vernier scale, actually it may vary from vernier scale, different vernier calipers. For usually the least count, okay, we'll calculate and then I'll tell you. So on this vernier scale, here we can see there are again 10 divisions. But what we can observe from here, when we, this is called jaw of this vernier caliper. This is one jaw. This is one jaw of the vernier caliper. This is another jaw. Right now they are closed. That's why 0 of main scale is exactly coinciding with 0 of the vernier scale. In this situation, we can see that 10 divisions on the vernier scale is matching with 9 divisions of main scale. So definitely it's not 1 centimeter. But anyways, okay, so if we want to find out the least count of vernier scale, what we do, the formula is like this. The least count, it's also called the vernier constant. Least count and vernier constant are same thing. It's also called vernier constant. So how we calculate is 1 main scale division minus 1 vernier scale division. So 1 main scale division means on this main scale the smallest division is how much? So I told you 0 to 1 is 1 centimeter and it's divided into 10 divisions. So one division is 0.1 centimeter, that is 1 millimeter. So one main scale division is 1 millimeter. Now we want to know how much is one vernier scale division. So this is vernier scale, and how to find out how much is this one vernier scale division. So since we clearly see, let me write here, since we clearly see that 9 vernier scale divisions are exactly coinciding with, I'm sorry, 9 main scale divisions is coinciding with 10 vernier scale division. This means that once vernier scale division is equal to 9 over 10 main scale division. So here we can write 1 vernier scale division is 9 by 10 main scale division. Which this means 1 millimeter minus 9 by 10 millimeter. This means 1 over 10 millimeter means 0.1 millimeter. So now this way we have calculated the least count of a vernier caliper, which comes out to be 0.11 millimeter. So with the usual 15 centimeter or meter scale that we have, which has this kind of scalings, with that we can only measure up to 1 millimeter. The least count is 1 millimeter, means 1, 2, 3 millimeter we can measure. But using vernier caliper, we can go to 0.1 millimeter. That means it's 0.01 centimeter. So we have got, now we can obtain up to one more precise decimal value of anything that we'll measure. Another thing that we need to, okay, so if we measure anything using vernier caliper, first thing we need to take into account is the zero error in the instrument. So it's very important to first know the zero error of the instrument before we carry out any measurement. So the zero error right now for this particular picture, if we'll see, the zero of this main scale and the zero of the vernier scale, they are exactly coinciding. So for this particular vernier scale, we can say that it has no zero error. So there is no zero error existing for this particular scale. But say if say that say this is the zero of main scale, these are the scalings, say this is main scale and this is vernier scale, and the zero of vernier is not coinciding, but say, sorry, uh, is everything like, am I audible and the screen is visible? Because nobody is asking anything, I'm doubtful. Can anyone say, is till now is everything clear?
Hello, ma'am. Ma'am, you are audible and the screen is also visible.
Okay, thank you so much. Okay, we'll continue. Okay, so uh, this is the main scale, zero of the main scale, and don't confuse, this is nothing. Okay, let me again make it full screen and pen. Yeah. So if this is the main scale and this is the vernier scale, and say the zero of the vernier scale is starting from here, and these are again the these, say that these 10 are the scalings on vernier scale. This actually happens, this can happen that the instrument is very old, it has got rusted, or got broke or bent due to these kind of things. I mean, from the factory when we get, it should be without any zero error. But after a long time, there could be some reason, again, it got old or it got bent, it got damaged, because of which the zero of main scale is not exactly coinciding with zero of vernier scale, as in this case, and now they are shifted. So if one situation is, if the zero of vernier scale is shifted to the right from the zero of main scale, in this situation we call it positive zero error. There is another situation, so again I am repeating, when zero of the vernier scale is to the right of zero of main scale, it's called positive zero error. So I don't have new slide. The another situation is, if again say this is the zero, these are the scalings, this is the zero of the main scale, and this is now zero of the vernier scale. In this case, the zero of the vernier scale is on the left of the zero of main scale. This is called negative zero error. Now what we do with these zero errors? See, if we measure without knowing about these kind of zero errors and we make any measurement, that value will not be correct. So that's why first we need to know if there is zero error. If there is no zero error, it's fine. If there is zero error, then what kind of zero error it is? Is it positive or is it negative? Because when we measure anything using these vernier calipers, we'll take another slide. This space is not sufficient. Okay, so say measuring any, because the when we measure something, how we measure for this using vernier caliper is the total reading we get is main scale reading plus vernier scale reading into the least count minus the zero error reading. So we need to know what is the zero error to get the correct value of our total reading. Actually, we can try this. I think I have some problem questions where we can see how to get the total reading based on this formula. Otherwise, if it's not there, then I can give some example and we can try there. So this is one instrument, vernier caliper. There is another instrument which goes to even more higher resolution, that it's give even more precise value because its least count is even smaller. So this is a typical screw gauge, how it looks. These are different parts mentioned. I don't think it's that much important for us. What important is that in this is called the main scale, and this similar to vernier caliper, here also this is called anvil and spindle, but you can again consider them like in previous case like two jaws, and you can keep whatever you want to measure, the length of something or the width of something, or you can also place any cylinder in between, and if you want to find out diameter of that thing, we can place in this gap. And after placing in this gap, we move this, this is a cylindrical part of screw gauge, which when you will rotate, it will tighten around that object, and this ratchet, when we turn this, it makes a sound. After that we know that okay, this gap is exactly of the size of the object and we should not press or turn this more. So that is the correct way where we should stop. Okay, so after this, this is same as the size of the object. This is the main scale, and this is called the circular scale now. So here also, how we take the reading is this main scale. Again, we need to check for zero also. But after we have checked for that, how we take the reading is where this these marks, these scales on the circular scale, where it is coincident with this line that is visible on the main scale, that reading we take. So actually, how we calculate the least count of the screw gauge is, to know the least count of screw gauge, first we need to, okay, so least count of screw gauge is given by pitch of screw gauge divided by total number of divisions on this, I'll call it CS, circular scale reading. On this circular scale, total number of divisions, and numerator we have pitch of screw gauge. So now what is pitch of screw gauge? So uh, when these two jaws will be completely in contact with each other, means there is no object in between, that time the zero of this main scale should again coincide with zero on the circular scale, and we will not be able to see this 5 and these scalings we will not be seeing, it will exactly be here. But when we start moving this, more of these scalings, linear scale, we will be able to see. So we want to know in one rotation of this circular scale how much of linear length we have covered. Means, for say for example, that in 10 rotations, so when I rotated it 10 times, on the linear scale I covered 0.5 millimeter. Here this is millimeter, so we covered, sorry, I meant, this is not, this is 5 millimeter. That when I made 10 rotations, we covered 5 millimeter. That means one rotation, with one rotation we the linear distance we traveled is 0.5 millimeter. So this 0.5 millimeter is actually the pitch of the screw gauge. That in one rotation how much linear distance we are covering, that is pitch of screw gauge. Now we will calculate the least constant. So the pitch of screw gauge is 0.5 mm divided by total number of divisions. Usually, okay, actually in this particular image, I think, I'm not sure, maybe it's 100 divisions or something, but the screw gauge is designed in such way that the least count is actually 0.01 centimeter. So in that way, if I have a device which has pitch 0.5 mm, that means its circular scale reading will be, so that means it's this will be 50, total number of divisions on circular scale will be 50, so that we will get 0.01 millimeter. So for vernier caliper, we had gone till, in vernier caliper case, the least count was 0.1 millimeter. With screw gauge we are getting even more precise value. In this particular diagram, if you're wondering, like it's not 50 number of divisions, I think it's maybe around 100. In that case, we don't know. I mean, if I'll turn this rotations, then maybe the linear scale that I'm traveling is different. That again, that's what I was telling. It may depend now different. Um, there are screw gauge and vernier caliper which come with even more precise values or that kind of situation. So it depends on different values. So it's better to always calculate the least count before we start doing the measurement. So I think this we have understood this little bit about screw gauge and vernier caliper. Now I think we can start with the previous year's assignment questions. If you have any questions till here, you can ask, or otherwise in between the problems you can ask, or after that as well. There is no problem. So let's start with the first question. The question is, in a given slide caliper is same as vernier caliper. So in a given slide caliper scale, smallest division in main scale is 1 mm. It's given smallest division in main scale is 1 mm, means the least count of main scale is 1 millimeter. The smallest value we can measure on main scale is 1 millimeter. The 20 divisions of vernier scale coincide with 19 divisions of main scale. See, this is what I was telling, that different vernier calipers may have different uh, changing divisions. It's not compulsory that all will have same. Okay, so here the 20 divisions of vernier scale coincide with 19 divisions of main scale, and they have asked us the vernier constant or the least count of the slide caliper. So we have to calculate the least count or the vernier constant of slide caliper. So we know the formula, that least count is 1 main scale division minus 1 vernier scale division. 1 main scale division is 1 millimeter, and 1 scale division, how we'll get to know? So it's given that 20 divisions of vernier scale, means 20 vernier scale division coincides with 19 divisions of main scale. 19 main scale division, that means 1 vernier scale division is equal to 19 over 20 main scale division. And since one main scale division is 1 millimeter, that means this is 19 over 20 millimeter. So once vernier scale division, from this relation we obtained, it is 19 by 20 millimeter. So it will be 20 minus 19, 1 over 20 millimeter, and this will be how much? Wait, just to be correct, I will use calculator. I think it's 0.05. Yeah. So 1 divided by 20, sorry, it's 0.05. Did I make some mistake? Can anyone see and tell me? Hello? Does anyone think
Madam, you have to
Yes, yes.
multiply with that 1 mm or something. Main scale reading, on main scale
Yes,
reading.
yes, yes, yes. Right, correct. Okay. Yeah, so no, I'm sorry. So we have to calculate the least count, which is one main scale division minus one vernier scale division. Now 1 millimeter minus 19 by 20 millimeter. Uh, mm, if anyone else would like to say something.
Madam, in this lead count, one MSD minus one VSD cell. This
Sorry?
one here in this least count formula
Yes.
into one main scale reading is coming. And SAR presented, and that he multiplied with 0.1 centimeter.
That is when we measure the reading, total reading you're saying, right? That is one main scale reading minus one vernier scale division into least count. That formula is for total reading.
Okay.
Just give me a second. Yeah, okay. So I think the options, there's something wrong with the options because I think our calculation is correct. Vernier constant of the slide caliper. I think our calculation is correct. I'm sorry, whatever you were saying, I think you were talking about reading, the total reading. I don't know, I mentioned or not. Let me check. I explained the least count. So let me tell you how we do the total reading. So the least count formula is correct. 1 MSD minus 1 VSD. When we take the total reading is one main scale reading plus the number of vernier scale divisions that we get, number of vernier scale division times the least count and then the zero error. Then the zero error. This is how we take the reading. But for least count, it's one main scale division minus one vernier scale division. This is correct. I have just copied this previous assignment. I think there is some mistake here, or maybe the option is none of the above in that case, because our formula is correct and it should come 0.05. If 1 over 20, I think it's correct, it should come like this. Okay, so moving to next question. The image of vernier caliper is shown below. Identify the nature of zero error, if any, in this scale. Just So this is the vernier caliper image. This is main scale, this is vernier scale, and as we can see, this J1, J2 are the jaws of this main scale and this vernier scale. They are attached, means there is no instrument in between, it's completely closed. When it's closed, we see that the zero of main scale, it's not coinciding with the zero of this vernier scale. And if you remember, I had told about two situations. If zero of this vernier scale is on the right side of zero of this main scale, then it will be called positive zero error. But here we see that the zero of vernier scale is on the left of zero of main scale. This means it's a negative zero error. So, uh, this is the correct answer here. And I think, I'm sure in this, I think none of the above is the correct answer. I missed to see that we have this option also. If it's not matching, it's our calculation is correct, but option it seems is this. Okay, so the third question, a vernier scale with positive zero error. Okay, now we need to see that it's already telling that there is a positive zero error of 0.3 millimeter, gives following reading in measurement of diameter of a wire. So we are measuring diameter of a wire. Okay, so yeah, this is a wire, this is the diameter, say so we are using vernier caliper, right? So it will be a diagram like something like this. I think the two jaws will open like this. This will be main scale and the vernier scale will be here. Between these two jaws we'll keep the wire. So this is just magnified, no wire is this big, but yeah, if it's magnified view, this is the diameter of a wire. And now it's saying main scale reading is 5 millimeter. So I think from this problem, your question, if there is some doubt, it will be cleared that how do we take the reading if we already know least count and those things. So we should see least count is given to be 0.1 millimeter. It's written least count of scale, but what it means is least count of this vernier scale. So least count of vernier scale is 0.1 millimeter. So here we don't need to calculate, it's already given to us. Now main scale, so we know the formula that if we want to get the total reading, then it's it's main scale reading plus vernier scale division, number of vernier scale division, actually number of vernier scale division times the least count, plus zero error. So main scale reading here, it's given that the main scale reading is 5 millimeter. So main scale reading is 5 millimeter plus number of vernier scale division. Here it's given vernier reading is 4 divisions. So actually this vernier reading, we don't take it in millimeter or anything. We just count the number of divisions. In case if you want to see this we know it's in centimeter, and we take it like this, that this is 1 millimeter, 2 millimeter, like that. But for vernier scale, it's not 1 millimeter or anything. We just count it as 1 division, 2 division, 3 division, or however it is, but it's like in divisions. So here it's given 4 divisions. So number of vernier scale division will be 4, and then the least count, which is given to be 0.1 millimeter, plus the zero error. Zero error is positive and it's 0.3 mm. So it's positive and 0.3 millimeter. I think I made a mistake. The zero error is to be subtracted actually. It's not added, it's subtracted. We need to remove the error. So we subtract it from our total read, from our reading. So this will be 5 millimeter plus 0.4 minus 0.3. 0.4, I think 5.1 millimeter. So this measurement that we have done, this is for the diameter, and they are asking us to find the area of cross section of the wire. So cross section of the wire, area of cross section means this pi r square we need. So this is actually the diameter. As mentioned in the question, this is diameter. So what we have calculated is actually the diameter. In that case, this will be pi and 5.1 divided by 2 whole square. So this will be the area that we need to obtain. And okay, again I used the calculator for this. If anyone also, I'm not sure you guys are also doing it simultaneously or not, it would be better actually. Maybe from next time we can do this way, that I'll ask you guys to calculate and then wait, and if anybody gives answer then we can discuss it. But okay, for time being I'm doing this. Okay, so what I've calculated in calculator, I'm getting 20.41. So I think 20.41, if we only take it to 20.41, I'm getting, this will be in millimeter square, of course, its area. So if we'll approximate it to single decimal digit, we'll get 20.4 millimeter square, which is this. Actually these are all squares, I'm sorry, it's written like 2, it's millimeter square, all of these. And yeah, I had made the mistake. It's a positive zero error, and it needs to be subtracted from our reading so that we get the correct reading. So this has to be subtracted. Please keep in mind the correct and this formula. Moving on to next question. Okay, this question is based on screw gauge. So as shown in image below, the least count of this screw gauge is given 0.01 mm. Least count is given to be 0.01 millimeter. How much is zero error, if any, in it? Okay. So I hope you guys are able to see this image. Here if we see, when these two jaws, or they have some different name, but if we call it jaws, they are completely touched with each other, and we can see that the main linear scale mark and the zero on the circular scale, they are completely coinciding. Since they are completely coinciding, that means there is no zero error. So we do not need to consider this, but there is no zero error. We can say there is no zero error. So there is no zero error. Next question is, measurement done by a screw gauge of least count 0.01 millimeter and having no zero error is shown in the image below. The reading in this measurement will be. Okay, so again here we need to consider the total reading. Let's start here. Again, total reading will be linear scale reading. So in vernier caliper we call it main scale and vernier scale respectively. Here in screw gauge it's called linear scale because it's linear and this is circular. So the total reading formula becomes linear scale reading plus vernier scale divisions times the least count and minus the zero error. Again, it doesn't have zero error, so it's okay, but otherwise this is the formula. Now we can see in this image that The linear scale, this is 15 centimeter, this is 20 centimeter. So I think this is, oh wait, this is 15 millimeter actually. This is 20 millimeter, this is 21, this is 22. So the circular scale has just crossed the 22nd mark. We still cannot see the 23rd mark on linear scale. That means the linear scale reading is 22 millimeter. 22 millimeter plus. Now we need to say how many sorry, this is circular scale division, I'm sorry. This is circular scale division. How many division? Okay, we'll see here. So this line of the linear scale, this straight line on the linear scale, it's coinciding with this particular mark on the circular scale. So how we'll count is, this is 30th division, this is 31, this is 32, this is 33. So it's exactly coinciding with 33rd division. So vernier scale division will be 33 time, and the least count is given to be 0.01 millimeter, and there is no zero error anyway. So 0. So what we get is 22 plus 0.33 millimeter. That is 22.33 millimeter will be the reading for this particular problem. So the correct answer is 22.33 millimeter. Okay, so next question is, one vernier caliper scale is shown in figure below. What kind of error is there in the scale? Here it's mentioned that the top scale is the main scale, the bottom scale is the vernier scale. Now again we need, how we calculate the zero scale is, we completely close the two jaws. This is vernier caliper. We completely close the two jaws and we check if 0 of main scale and 0 of vernier scale respective to each other, where they are. In this particular case, 0 of main scale and 0 of vernier scale is completely coinciding with each other. From this we can say that there is no zero error again. So in this case there is no zero error. Now next question, how much is the least count of this vernier scale? Okay, so I think it's the same vernier scale image that was in the previous question, and for this vernier scale, now we know there is no zero error. Now we just need to find out the least count of this vernier scale. So again, first I think this is the best way. First if we write the formula and then put the values, it will be better. So least count is 1 main scale division minus 1 vernier scale division. 1 main scale division is, we can see it's again 1 centimeter, 10 millimeters. So the least count of main scale is 1 millimeter. So 1 main scale division here represents 1 millimeter. And 1 vernier scale division, again how we'll find, we can see here that 10 divisions on vernier scale, that is 10 vernier scale division is equal to 9 main scale divisions. This means 1 vernier scale division is equal to 9 by 10 main scale division. It is 0. Or we can write it as, so this is 0. So least count is 0.1 millimeter or 0.01 centimeter. Here we have in millimeters, so the correct answer will be 0.1 millimeter. The next question here is, okay, so this next question, let's see what it is. Ideal voltmeter is connected in a DC circuit as shown in diagram below. So voltmeter, we usually know voltmeter is connected in parallel. Uh, it's connected in parallel to the thing across which we want to know the voltage difference. Like if we want to measure the voltage drop around this resistor, then we'll connect in parallel. Usually that's how we use a voltmeter, because voltmeter has very high resistance. But okay, in this case they are saying that is connected in the circuit as shown, and the battery has zero internal resistance. What will be the reading of the voltmeter? So as I mentioned, that voltmeter is always connected in parallel with the whatever device across which we want to find out the voltage drop, because voltmeter is made in such a way that there should not be any current flow through the voltmeter when it's connected. Say okay, let me draw a diagram here. Usually say this is a battery and this is some resistance, and this is some battery, this is the resistance across which I want to know how much voltage drop is there. So we connect the voltage in parallel with this resistor. In this case voltmeter is made with very high internal resistance, so that all the current will flow through this resistor and there is no current through this, so that we can get correct value of we can get correct value of V, I times R, because all the current will be flowing through this. So this is how usually we use voltmeter. But here they are saying it's connected in series, not in parallel but in series. And since voltmeter has very high resistance, that means the current in the circuit will be zero. Because it has very high resistance, the current in the circuit will be zero, and thus the voltage will be, there will not be any current flow, and the voltage here will be showing zero. The answer will be zero. We are not supposed to actually use voltmeter like this, but for this particular question, if it's connected like this, then there will not be any current flow, and the voltmeter will show zero reading. Okay, so next question is, in the previous question, if resistance of voltmeter is 990 ohms, the current in the circuit will be. Okay, so instead of very high resistance, say like for just for this problem, they are saying that assume that the resistance of voltmeter is 990 ohms. In that case, the current of the circuit will be. So in that case, we know, so we need to find out current. So current is voltage upon resistance. Here the total resistance we see, first we have this 10 ohm resistor, and then voltmeter is connected in series with this resistor. So we know the total resistance will be 990 ohm plus this 10 ohm resistor, will be 1000 ohm resistor we have in series. So the current will be voltage, okay, so so this will be, I think this will be 0.01 ampere. 0. Voltage and ohm, right? So it will be ampere. But in options we have 1 ampere, 1 milliampere, 1 microampere. If we'll convert this into milliampere, it will be 10. Yeah, I think 1 ampere is 1000 milliampere. That means it should be 10 milliampere. Okay, but again I don't see 10 milliampere in our answer. There is 1 ampere, 1 milliampere, 1 micro, 10 ampere. I think again maybe there is some mistake in this option, because the correct answer you all can calculate and verify. The correct answer would be 0.01 ampere, because the units are volt and ohm, or if we convert it to milliampere, it should be 10 milliampere. Okay, moving to next question.
Excuse me.
Yes, yes.
What was the answer to the A question?
Of which question?
It. Okay, thank you.
Do you have any doubt in this?
Yes, can you explain it in short?
Yeah, yeah. So, actually, voltmeter is a device. It's supposed to. Should I explain you this also, or I mean, I just for your understanding, I don't have any issue. I'll explain it again. So, voltmeter is for measuring the voltage drop against any resistor. Okay. So, usually voltmeter is connected in parallel. So this is a circuit, simple circuit. This is a battery of again say 10 volt, whatever. So this is a resistor, and we connect voltmeter to know how much voltage is dropping across this resistor when the current is flowing. So voltmeter is designed in such a way that it's what we say, its internal resistance is very high, maybe more than mega ohms or something. It's very high. It's very high so that there is no current doesn't flow from high resistance, right? We all know, we say that it follows the path of least resistance. So when we have a resistor and a very high resistance together in parallel, the current will not flow from this direction, it will just flow from this, and then we'll be able to measure the voltage drop across this particular resistor. So this is how usually voltmeter is supposed to be used. But in this particular question, this voltmeter is connected in series. Instead of connecting it parallel, it's been connected in series in this particular circuit. Now, since the voltmeter has very high, we can ideally say it has infinite resistance. In that particular case, if there is infinite resistance, there will not be any current flow in this circuit. We know how we calculate this formula is V is equal to IR. If there is no current, the voltage will be zero shown. Okay, I hope that's clear now. So we never connect voltmeter like this, but for this particular problem they have asked us, so the voltmeter will be showing zero reading. Is that clear?
Yes, thank you.
Okay, thank you. Okay, so this we did. Now moving to this question. The question is, we have been given a value 28,265. Rounded off to nearest thousand is. Again, actually in measurements, these rounding off and how many significant digits are there, these things are of importance depending on the situation, how much precise we want to show our measure value and these things. So rounding off is also important aspect we should be aware. And I think, okay, I can tell, but I think we already know the rules of rounding off. Say we have a digit like 32, right? If we want to round it off to 10 digit, since if we want to round it off to 10 of digit, then we know this unit digit is less than 5. That means if we round it off, it will become 30, right? If instead it's 37 and we want to round it off to 10 of digit, then since this unit digit is more than 5, so it will become 40. I mean, we all are aware of these things. So similar thing here, we need to round it off to nearest thousand. So ones, tens, hundred, thousand. That means we need to round off these hundreds to the thousand. Now these hundred, I mean this ones, tens, hundred, this value is, let me write here, this is 2, 8, 2, 6, 5. This is unit, it's 10, 100, 1000, 10,000. This is how we count, right? So we need to round off till here. That means we need to consider this 265. This value, since it is less than 500. So we'll round it off and it will become 280, and the correct answer here will be then, the correct answer will be here, this. If let's say it's 28665, and again we have been asked to round off to this tens of digit, sorry, 1000, then again we'll see this and we'll see this that it's more than 500, or we can say that this particular digit is more than 5. So we'll round it off here to next higher digit, that will be 29000. I think this is clear. I think it's already clear to everyone, but still if there is any doubt, you guys can ask. So for this question, 28,000 is the correct answer. Next question is, a wire of resistance R ohm, okay. A wire of resistance R ohm is stretched to 4 times its original length. Now the stretched wire is cut into 4 pieces of equal length, and okay, let me just draw this thing. So we have a wire whose resistance is R ohms, and next it's stretched to 4 times its length. So initially its length was, say, let's call it L0. Okay. Like they have not mentioned, so we'll assume that initial length was L0, and now the new length I can call it L1, and they have mentioned that it's stretched to 4 times its original length, means this L1 is actually 4 times the old length, 4 times L0. Now the stretched wire is cut into 4 pieces of equal length and then connected all these in parallel. The new resistance of this combination will be, see, we know that resistance of any object is proportional to its length and inversely proportional to, of any wire, cross-sectional area, and that's how we get that formula also, right? This. And resistivity depends on the material, it doesn't depend on the dimension, it depends on the material, so it's a constant value. Anyway, so we need to find out, earlier its resistance was this, now its length is changing, and since they have asked that assume that there is no change in volume due to stretching, that means volume before and after is same. If volume is constant, that means let's say this, so volume before and volume after, they are same. I'm just denoting this zeros for before and 1 for the new dimension. So volume is same. If volume is same but length has changed, so this is a wire, right? Wire means cylindrical. So wire will be something like this, like it's a cylinder. Volume of cylinder is actually area of cross section times the length. So let's call it area of cross section into length. Length was L0. Volume is still the same. Now we'll call the area of cross section A1 and the length L1. Now volume is still same but length has changed, that means the area of cross section will also change. Now we need to find out, because why we are doing this, because we want to find out how since resistance depends on length and area of cross section, so if my length and area of cross section has changed after stretching the wire, that means my resistance would have also changed. Okay, that's why I want to know L1. I know L1 is 4 times the L0, but I want to find out A1. So wait, A1 L1 is 4 times L0, that means A1 is okay. So L0, L0 will go. A1 will be A0 by 4. This is my new area of cross section will be A0 divided by 4. Now I want to calculate the resistance. Okay. So this new resistance will be new of new length, which is new length divided by new area of cross section, which is 4L0 divided by A0 by 4 will be 16 times the resistance of the the previous one. But okay, so earlier so this is, we have found out that earlier this wire's resistance was R. Now when we have changed its dimension, it has its resistance has become 16 times the old value. But that is not the question. The question that we have been asked is the new resistance when this new wire is cut into 4 pieces of equal length and connected in parallel. Okay, so this whole stretched wire, this whole wire is cut into 4 equal pieces, and this whole wire's resistance is 16. So when we'll cut it into 4 pieces, each piece will be 4, actually it will be 4R ohm because R0 was R. 4R, and we know in parallel how we calculate is 1 over R plus 1 over, sorry, 1 over 4R plus 1 over 4R. Yeah. 4. My pen. Okay, now at least I think you guys can calculate this and tell me. Somebody, please try. I want to see if I am being followed properly or not. We have half an hour and we have few more questions, but I have solved half of this question. Can anyone try and tell me how much is it?
4R.
What exactly is 4R?
The new resistance.
How did you calculate?
The parallel. Uh, in parallel, like if you combine two elements of the same resistance, it will become half. So we have 4 of the same resistance, and it will become a quarter. Like that.
Okay, so that is also correct actually. Okay, in that case, it's fine. I think others can also try, otherwise we'll try. I'll tell in by the end of this lecture. But otherwise, let's go to the next question. So this should be, or you can still think about it because only one person is able to answer me right now. Okay, moving on to the next question. The device shown below may be used to measure. They've asked the device shown below may be used to measure mm, current only, AC and DC voltage only, resistance only, all of the above. So here we can see that this is called a multimeter actually. Here I hope this image is clear. This is voltage. So that means we can measure the voltage also. This is A means ampere, means we can measure the current also. And these marks, this we see it's written ohm. So this is the mark for DC voltage actually, and this is the mark for AC voltage. Means we can measure both in AC and DC voltages here. We can also measure the resistance here. We can also measure the current here. That means we can measure all of the above here. We can measure all of the above here. Oh, okay. So only these were the questions that I got from previous year assignments, and actually, if you guys have questions from this time's assignment, I think the submission date is 7th August. So either you guys have already solved it or are going to solve. Uh, I cannot actually solve those questions for you, but if you have any specific doubt, maybe you can ask and I can answer. Does anyone have questions regarding this time, or maybe after watching the lecture, if you guys have any questions? So no one has any question, is it?
Are there any books for this course?
Oh, uh, actually this course seems to be very basic what sir has kept. So I'm not sure we'll be able to find out books because he is teaching very different kind of things he is trying to keep together. Mm, but okay, I'll keep in mind. I'll go through what he would have suggested somewhere. I'll go through it, and I think in next class I'll surely let you know if there is some specific good book that he has suggested. Okay, thank you for asking this. I'll keep in mind. Next time I'll be able to tell you some book for it. But I think yeah. Basically, actually, the things that he is teaching in this class, it's all these things have been taught in 11th and 12th standard. So I think that's why the lectures are not in that much detail. But still, okay, if you want to go through some text, I think we should have. I think somebody is saying something in chat. I don't know. I'm not able to access the chat. For this course, there's a column in website book. There you will find the book. There's a column in website book. Sorry, I'm not understanding, Aditi. What do you mean by that? Can you explain me what do you mean by column in website book? So that others can also check out. On the website, do you mean NPTEL website? They have suggested some book. Maybe we can check from where we watch those assignments and videos. Okay, yeah, Adi. Maybe on the website there we can check. I think there must, I think, would be mentioned some books. I have not checked, but yeah, maybe you can check and I'll check and anyway let you know in next class. Okay, any other question? But I have a request, just, yeah, okay, thank you. That either I should wait more time, maybe next time, because what was happening, I don't have any issue of anybody joining anytime and leaving, but like when I already start presenting, and every time notification comes, so I have to close that window and let the person join, and then again I have to open my presentation. And so I mean that others are also I mean already going through the session, right? So it's interruption for them also. So maybe okay, I'll wait little more time for next class so that more people can join, but still try to come and join as soon as possible so that we can start the class. Is there anything in the lecture or any? Yeah, I think there would be some suggestions. You guys can tell me directly so that I'll uh, try to keep that in mind. So this is my first class, and today I'm having issue with the writing pad and pen also. But I think I'll by practice that will also be better. Then yeah, today I think on my PPT slides also there were a lot of maybe the font was not clear and these things. But apart from that, if you guys have any suggestion, please let me know. Okay, I think some people were writing answers also. I'm very sorry, I was not able to see the chat actually. This is a problem when my presentation is in presentation mode, it's covering the whole screen actually. So I'm not able to see anything else apart from that slide. So it's nice to see people like Aditi, you were mentioning this. Oh, you were answering the questions actually. Thank you. But yeah, I could not see the chat. Sorry. I think then in that case, next time maybe I can give you guys 1 or 2 minutes to solve, and then we can discuss the solution. What do you think about this? I think we can do this so that that will be a better interaction as well. Okay, Prasad, you are sharing the Google Drive link. Can we open this? Okay, okay. Oh, it's a book by Professor Das himself, it seems. It's a very big book though. Okay, it seems he has compiled his slides and the explanations he was giving. Okay, maybe we all of us can go through this book later. Thanks for sharing. Thank you very much. I think we all can go through this and see. Sometimes actually it's not very convenient to read so much of text, right? So that's why I think if you go through the lectures that are there for every week, and then if there are some doubts, we can discuss in this kind of interaction session every week so that you guys can attempt those assignments, because this book seems, I mean, it's too much to read kind of thing. So anyway, okay. But yeah, if anybody wants to go through it, please, this drive link is there. And after this session, I'll share this video. We have to upload it on YouTube. There you can access this. Also, I'll share these slides so that you can go through it as well. So if there is anything more, please let me know. Right now I can see the chat, so if you can put in chat also, that's fine. And okay, so this week's all lectures were okay. I mean, vernier caliper, screw gauge, I think, and rounding off or significant. Okay, if there is nothing, then maybe we can close today's class. Should I? If anybody can respond. Okay. Okay, thank you. Then, okay, I'll stop the presentation. Oh, okay. Okay then, bye. We'll meet each other next Saturday, same time, 3 to 5. And again, I think second week's lecture are already made available. So please go through it, and then whatever doubt you have, become prepared so that we can discuss accordingly, because I cannot solve this year's assignment. So only whatever I'm getting from previous year, I have those questions only. So if you have any doubt or something is not clear in the lectures, you can ask me next time. Like, note it down and then you can come with your questions. Okay, with that, then I think thank you very much for joining, and we'll see you. Bye.